Let's assume we have a text. Oh, let's change the color to the black. We have a text as A, Y. I'm doing some, random B, 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 F, X, Y, Z, and G. We'll say this is our text. And the pattern is A dot, B star, F dot star. I tried to make an example that you will see single dot, a letter dot, which is here, B star, and dot star, to see all the combination in one single example. Let's go and check manually for this example if the text matches the pattern. So A matches A, and actually we have to be aware of the next character in the pattern. And as you can see here, A after A is dot is not a star, because if we have a star, we have another meaning, right? We have another interpretation for a star. So for each character we have to check the next character in pattern. Because A, we have A in pattern right now, and the next character is not a star, so we can simply check the matching condition for A and A. A is A, so we have A in the string in the text, A in we have A in text, we have A in pattern, so it is matched. So we can go forward 1 unit for both in the text and in the pattern. We have dot in pattern, and the next of dot is not star, is not a star, so it means that dot means only a single character. And we have Y, so it is matched. So let's go to the next character. We can move these guys. B is here and B is here. We have to check the next character of B, which is a star. It means that we can have let me erase this to make it a little better. The B star, and the index is here. B star means we can have 0 or more B's, and we see in the text that we can match all of the 3 B's with this B star, right? So we can match all of these guys, and I can move this here over the F. And also we did all the thing we could do for B star, right? And then let's say we will go forward to F. F, the next of F, the next sector of F is not a star, so we can only simply check this with the current index of the text. They are matching, and so we will go forward. And here we have dot star. Dot star means any combination of characters, no matter what is the length and what are the characters, right? So for these guy, we see that this is the last part of our pattern. I can sweep, or I can parse all remaining characters. So I can parse all of these guys. At the end, as you can see, we can go outside of we can increase our pointers or indices to outside of the text and pattern. And finally, we see that text matches the pattern. So, and it is matching like this. Let me A and Y, and these guys all are matched for B star, and these guys are matched for the other star. Let me write on top. B star, and this is dot star, and A Y, and this guy also is dot, and we have F here, we have A here, and that's why we say the text matches. So we will return true for this example. Okay. Now it's time to go based on the example, think about how we did the decision making, how we decide about how we can go forward, and based on your awareness about your manual solution, or what's going on in your mind, in your brain, you can convert it to the algorithm, and you can detect which pattern will be really helpful for you. As you can see here, in every session, for every character in pattern, we have two cases, right? As you can see, we say the next character, let's say my index is here, and the next character is a star or is not, right? So if I go based on pattern, which is really important, the pattern, because based on pattern we want to match the text, right? So let's say I have a J index for pointing the pattern, and I is pointing for traversing the text. So if I'm in J 0, what is my next my options actually for every J? What are my options? Actually we did in the example, right? So we are in J, and we have two options. Pattern J plus 1 is equal to, let me write a single called star, or the pattern J plus 1 is not equal to star, right? As you can see, we have two different options, and these two options will cover a whole search space. When we see that when we are thinking about a problem, and the problem goes in this direction, that we see that we can divide whole search space in two sub problems or two sub search areas like this. We have star or we don't have. It should remind you the dynamic programming pattern. It should remind you recursive solutions. And if you have recursive, as I said, you can go convert it to the memoization and then to the tabulation. So we have a star or we don't have a star, right? If we don't have a star, it is really simple, right? This is really basic. Let's say I'm gonna go in here. If we have a star, if we don't have a star, it means it is we have a single character or we have a dot, right? We can check the matching pattern, matching criteria really simple. We can do that simply, so we don't have any challenge here. But let's say we have a star. What will be happened? If you remember, for a star, we had two different counts. 0, the string with the length of 0, or more of the previous character. For B star and for dot star is 0 or more of any characters, right? So for a star we have 2. Based on this, you don't have any do lots overthinking. You need to only convert your problem-solving decisions you did for the for the example, right? Or actually, you are converting all the assumptions to your code or your algorithm. So if you have a star, let's say the next one is star, we have two choices, right? So let me name these guys, 1, 2. And here we'll have 1A, 1B. Well, let me, A is not good. 1, 1 and 1, 2. Okay. 1 means we don't want to generate anything, the empty string. 1, 2 means we want to generate, or we want to actually match. We don't want to generate. We want to match. Let's say will be pattern. Let's say I want to put the pattern in pattern J. We will have repeat. We know that the pattern J is a letter, and the next character is star. So we will have n, which is greater than 0, because we did the n 0 is here on the top, right? So we can have empty string, or we can have n greater than 0. So as you can see, we have one level for based on the star for the next character, and if it is not a star, we don't have any sub problems. We can simply check the the pattern matching criteria. But we have a star again. We have two options. It can match a string with 0 characters. Also, it can match a string with any characters. So we have to handle them in two separate sub-problems. So based on this structure you see here, we can formulate our recursive solution. And I want to do this here. I hope I can write this guy here, but I think it is a little difficult to write all of these guys in the same place. But you can remember, and I will switch the whiteboard to the previous one if I need. So let's go ahead and write the code. So write the formulate the recursive calls. As you can see, we have I to traverse the text, J to traverse the pattern. We need text, we need pattern as inputs, right? So let me write the signature of the the function here, and then we will go and write the definition of the functions in the next whiteboard. So let's say I want to define is matched, and in the top level we have text and pattern. But we know that in order to handle all the recursive calls, we need to have two indices. That's why we need to define a helper. So we will write return helper. Helper means you can name this is matched recursive. But in my classes, actually, I try to make really shorter names to make it really simpler. But in the real projects, I don't do these kind of namings. The namings should be really meaningful. So we have text pattern I, which is, what is the initial value for I is 0, initial value for j is 0. So that's why we are right now, we are ready to write the recursive part, which is the important part, the main part of our the algorithm. So actually we want to define this guy in the next whiteboard. We have I and j, and we know the sub problems. The next character can be star, or it's not a star, and if it is a star, we can match 0 characters, or we can have one or more characters. And based on this fact, we can go and write the formulate our recursive functions. The background, I want to have this guy. Okay, let's go and write the code. I want to repeat here actually even the top level. Is matched. We have text and pattern, and we want to return helper text pattern 0 and 0. Let's go and write the helper, which is text pattern I and J. So first of all, I go always I put some space for base cases. I don't write the base cases at first because I think it is really critical to have accurate base cases for recursive solutions. So that's why I prefer, and I strongly recommend you guys write first the recursive for calls, and based on that you can decide about your base cases, and you will see how I'm doing this. So this part is for base cases. I will do it later. So we said we have two high-level options, right? The next character is star or it's not a star. So let's write them. Let's convert those guys in code. So I will write this here. I'll say, if j plus 1, I want to check the j plus 1. So I have to check if it is inside of the pattern. Whenever you are working with the arrays and lists, before, and you want to play with, the indices, decrease or increase, you have to check. If you are increasing, you have to check the upper bound. If you are decreasing, you have to check the lower bound. And then do your condition, comparison or condition. And pattern j plus 1 is equal to star. Else. So this is let me write this in another color. This is the case 1, and this is case 2, right? Case 1 and case 2, we talked about it. Case 2 is, it is not a star. It means that we can go, we can match the current character and then call the remaining string as a sub problem, right? Let me do this here as an example. Let's say we have A, B, C, D. This is our text, and the pattern is A dot C star D. Okay, this is the text. This is the pattern. So right now, actually, as you can see, the J is here and I is here. The next of J, or J plus 1, is not a star. So what we have to do, we have to check if the current character is matched. If it is not matched, we have to return false, right? Because we found a mismatch. If it is matched, we can call same problem, same function for the remaining strings, because we know that so far everything is matched. So I can increase I by 1, I plus 1, I can increase j plus 1, and call the same function with I plus 1 and j plus 1. And I'm assuming it will return me true or false. And we don't want to worry about what's going on inside that function. In the recursive solutions, you have to assume that the right now, for example, for this problem, we are assuming that the helper will return us true or false for the text and pattern with the starting I and j. Text starting from I and pattern starting with j. It will return us if the text starting with I matches the pattern starting with j. So I'm writing here. I'm assuming I will. Let's say I know that there is a current match. I will write the code for this on top. Let's say the current match. I already calculated this, and it means it's calculating the current character in text is matching the current character in the pattern. And so we'll say if this is true, the current character is matched. So I have to call the helper function. Text, pattern, I plus 1 and j plus 1, because it is matched. And if it is not matched, so this will be false, and we will return false. So I forgot to write the return here. Okay, so if we have the case 2, it is really simple. We will write return current match and helper, and which is this is our recursive call, and we are assuming that this will return true or false for the remaining text and pattern. So let's I defined this guy here, but I didn't write the code for this guy. Let's go and check the current match here. Current match will be equal to. So in the current match, we want to check if the text of I is equal to actually the pattern of j, pattern in index of j, matches with the text in I. We have two conditions, right? If pattern is dot, it matches any string, any character. But if it is not dot, it should be equal to text of I. So that's why I want to write this like but before doing anything with the indices, I have to check if I is less than length of text, because as you can see here, we are increasing this guy here, and we have to check if I is in range. This is really the base case. So if I is less than length of text and pattern j is equal to dot or text of I, right? The pattern j should be equal to dot, which matches any string, any character, or it should be equal. So we can simply write this like this. If this is inside in dot or text of I. Simply we can write, check the current match with one line of code in Python, and I believe you have in the other languages also, in C++ and Java. So we checked here. Definitely we have to check this guy if the I is less than, I in the range, because here in the else we don't control I. We don't control I. And also we have to check the J. Maybe you are, talking about, why we are not checking J. And you will see that we will check J in the base case. But let's, assume that we are doing it in a correct way, because, in the base cases, you will see that we will check if the J is outside the pattern. It means that, J, we traversed all the pattern. That's why we keep this checking of the range of the J in base case. So as you can see, we have right now the current match. So we did the case 2 actually. So how about that case 1? We have a star. We said we have two cases, right? We can only sweep or parse 0 characters of text. What does it mean? 0 characters of the text. I'm writing here again, let's say return. We have 2 cases, right? We have to return 2 solved problems. We have to have 2 solved problems and OR them with each other, right? So the first one we said is we wanna sweep only 0 characters. What does it mean? We can write helper text pattern, because we don't want to match even the current character, right? We want to only parse 0 characters of the text. So it means that the current match is not important for the first case. Helper this, and I, we don't want to change I, but we want to move J 2 units. Or, so let me write this here. This will be case 1, 1. If you remember, I named this in this way. So we said I don't want to parse any character from the string, from the text. I simply should increase J by 2. Or I want to consume, or when I'm saying consume, I mean, we can parse 1 or more. So 1 or more, it means, we can parse 1 and call the remaining string. But only we need to increase index of text. I don't want to change. Let's say, here we have the example. Let's say we are here, C is here, and C is here, right? J is here, and I is here. One case is to simply, doesn't parse any C. We did this here, and we don't change I, and J will go to the D. Another way is to we can consume 1 or more of text, right? We shouldn't change J. J should be in the same. Oh, sorry, I have to. Yeah, okay. J can be in the same position, but we can increase I by 1 if C is matching. If C is matching the C here, right? So let me write this. If you see the code, it will be really easier to understand. So, or current match, it should be matched. If you want to match 1 or more, it should match right now, right? If it's not matching, it should be return. So we'll have current match and helper. If the current match is so, we can go 1 unit forward for the index. I plus 1, but J shouldn't be increased, because maybe we want to parse more characters. Maybe we have more. So this is case 1, 2. So now, as you can see, we formulated all of the options, or the cases we talked about it here. The first one, the second one, and the first. We have more subproblems. Actually, we have all of these guys now. Only we need to write the base case. So how about the base case? In order to identify what you should write in the base cases, you have to check the variables in the function calls. As you can see, text is fixed, constant, pattern is constant in all of them, so we shouldn't worry about them. But we are increasing I and j. So we have to check the upper bound. Because we are increasing them, we have to check upper bound for I. Both of them are increasing, so we have to check the upper bound. So we know that we have to check the upper bound for these guys. And so let's go and review the problem definition. We want to match the text with pattern. We are increasing j, and we are consuming some of or parsing the text character by character. When j will go outside of, let's say the points the outside of the pattern, means points it is equal to length of the pattern. It means that we did all, we traverse all pattern. Now I have to check what should I return, right? I have to check what should I return. And let's say j is here, but the I is not traversed whole text. It means that the text didn't match the pattern. But let's say the I is also in outside of the text. I mean I is equal to length of text. So it means that we traversed already all the text and the pattern is finished already. So we have to return true. That's why we can write our base case in this way. If j is equal to length of pattern, it means that we traverse full pattern. Why I'm not checking I? Because let's say I is the end of the text. I cannot make a decision. Maybe pattern is not at the end of the pattern. The j is not in the end of the pattern because we have, let's say, a star, right? Or we have a star, but we finished all the text. Like, let's say, I'm writing here, A, B, C, D, and we have A, B, C, D, D star for pattern. Let's say this is our text. This is our pattern. Let's say, simply we increase all of these guys and text is here, I is here, but J is here. J is pointing this guy and I is here. I is finished. We traverse all the text, but we cannot make a decision because we didn't finish the pattern. But for D star, we can generate 0 characters, and in the next step, J will be here, but I will be the same position. So that's why that's why we check the J. J has higher priority based on our problem definition. So if J is equal to length of pattern, we have to return true or false, right? If I is equal to length of the text, we will return true. If it is not equal, we have to return false because we didn't parse whole text and the pattern already is finished, so we have to return false. So now the recursive solution or brute force is finished. We have the brute force solution. Okay, this is the brute force solution. And now it's time to go and convert it to the memoization. The reason we are doing, converting the memoization to the memoization is that here we have a recursive, because we are calling one here and once here and once here, the recursive calls. And the worst case is this part. In every recursive call, we have two other recursive calls. It means that we have two power n. Actually, for this problem, the time complexity a little complex calculating that. I don't want to focus on that. Only you need to talk about. There are lots of math calculations to find it, but you can say that this is two exponential. Actually, it is 2 power something. It is 2 power t plus p times 2 actually, but I don't want to dive into those calculations. And even for in-area use, I think it is enough for this question, this kind of question, to say that the time complexity is exponential. Exponential with base 2. Why base 2? Because in the worst case, we have two recursive calls here. Okay, this is exponential. In order to decrease it, we need to do the memoization. And the reason we want to do the memoization is that we are sure that for these guys that we do, the recursive calls, definitely we call lots of repetitive subproblems. We call lots of repetitive recursive calls. Why? Because we know that what is the range of I for this problem? It can go from 0 to length of text, right? And J can also 0 to length of pattern. So let's say the length of text is T. I want to write this is, let's say this is T and this is P, capital T and capital P. So what is the whole, subproblems? Number of whole subproblems is T plus 1 times P plus 1. So this is the whole of the whole number of the subproblems. So why we have exponential? Because we do lots of repetitive recursive calls. So we need to save them in memory. That's why we say memoization. We have to save the result of each subproblem in a memory. Let's go and convert this guy to a memoization, and I'm using with the red color to differentiate it. Only you have some simple steps. First of all, we have to define the memo. So as I said here, we need I is changing from 0 to T, and J is changing from 0 to P. It means that a matrix IJ with the T plus 1 rows and P plus 1 columns is enough for this problem to save the result of all subproblems. So let's go and define a memo, which is a two-dimensional array. I want to create the reason I'm putting none, because the values, we know that is true or false, the results. I'm putting none to make it to show that we didn't calculate it. When you put none in these guys, you can create a integer matrix and put it -1, and you can say that 0 is false and 1 is true. But here in Python, we can simply write none, and I want to put none. It means that it is not, it didn't already calculate it, and I need to calculate it. None for in range length of, so I want to create first this one row, length of pattern. So this is one of my lists. Let me, yeah, I think it's good. I wanted to write the P, but I think it is good. So none for it. This is one of my lists, and then I wanna also repeat this guy. For, let me raise these guys. I want to repeat this for t plus 1. Actually, we should have a length of pattern plus 1, right? Or, yeah. Because if you are a Python programmer, you know that the range is not inclusive. So if I want to have P, I have to write P plus 1. For underscore in range len of text plus 1. So actually it is not really important, this is only the syntax. Please, you have to be really fluent in defining your the two-dimension array. Actually you can use hash map. Hash map is much more easier, but I want to go for this example using the two-dimensional array. But in some other examples, I will show you how we can create the memo as a hash map. And the working with hash map is much more easier. So we are defining the memo with the initial value of none. It means that we didn't have any answer yet. And we have to pass this to the function for a recursive function. Memo. So I have to also change this guy here. So before doing everything, only change all the signatures of recursive calls, because most of the time we forget to do this, guys. So that the first step, as I said, to specify the size of your memo matrix and define it here like this with here, and then update all your recursive calls. You have to update all of them before going to the next step. The reason I'm saying that, most of the time, even right now when I'm coding, we forget to add these guys. Usually I saw lots of people, they forget to add these guys. And after base cases, you should check before, actually it's better to say that before doing all of the recursive calls. So we do the recursive calls, all the calculations here. So before this part, we have to check if we already calculated for I and j. I mean, for I and j, if we have answer already in the memo, just simply return it. Simply we can return it, right? So we'll write if memo I and j is not none. If it is not none, so return it. with this returning, we're avoiding all of these, recursive calls. But if it is not, but if it is none, it means we need to calculate it. So we go to the next step. We have to check all the return parts. Before returning, we have to update the memo matrix. So I'm gonna raise the sky and put memo ing is equal to this. And don't forget you have to return it, because we just raised it, right? Return memo ing. I returned this guy. And simply in a similar way, you should raise the sky, and you will write memo ing. I'm trying to do here, let me make it a little, I don't have enough space, so okay, so we will write here memo ing is equal to this, and then return it. Simply we did two or three really simple steps. You don't need to think about the problem. Only the first step you need to think about it, and you have to check what are your variables ing, what are the range for these guys, and based on that we will define our matrix we did here. Pass and update all the function calls and memo in all of them, don't forget that. And then you will write if it is not none before all of the recursive calls. If it is not none, it means we have the answer. Simply return it. We don't need to do them. And then for every return, you have to save it in memo ing, because this is for ing, and return it. And also we did here, and it's done. And the time complexity, which was exponential with base of 2, will be, actually we talked about it before writing the solution, but time complexity will be as we said, right now we will have only, we will calculate all of these guys, right? All of these guys. And it's t plus 1 times p, but in terms of big O, you can write tp, will be time. And how about the space? The space, actually, we use this guy. And this will be tp. And we have a space, stack of space in all of these recursive calls, but because it is not more than t times p, in the worst case it will be t plus p, because of the levels of the the levels of our recursive calls. So that's why the worst case is this matrix, the memo matrix, and we have the space complexity of in the order of t times p. That's it, and we have one more step for tabulation, but right now, because I'm explaining, as you can see, you can do this in less than 1 minute, adding all of these red colors, and you don't need to think about it. You can do this really mechanically. In the next whiteboard, we want to convert this memoization to tabulation solution, and you will see it will be also easy, not as easy as the memoization part, but it is also easy, and a little you need to in one of the parts you have to think a little about how you want to actually formulate your for loops, how you want to populate. I will talk this in the next whiteboard.